Yeah, basically, we could probably kick this off. So, hello, everyone, and welcome to today's webinar called Unlock the Power of AI in Document Processing. My name is Ross Chorney, and I'm thrilled to be your host today. So, let me take a moment to introduce you the topic. So, recent reports shown that the Gen AI will add nearly a 10 trillion to global GDP over the next 10 years, and companies are already realizing a 3.5x of return of investment for every dollar they spend. However, according to Ernst & Young research, over 60% of business leaders are facing challenging in Gen AI adoption due to uncertainty around the technology. And indeed, many businesses find it challenging to figure out where to start on their transformative journey, how to use Gen AI to effectively drive growth, enhance the productivity, and stay ahead of the competition. And today, we are here to bridge that gap. Before introducing our fantastic speaker, Bogdan, let me bring a little bit of a context about Binariks. So Binariks is a technology consultancy company serving businesses all over the globe on different stages of their software development journey. As a company, Binariks has tailored its experience in some of the most highly regulated industries, including healthcare, insurance, and fintech, where precision, compliance, and security are non-negotiable. But while we excel in these vectors, our adaptability doesn't stop there. Whether it's retail, logistics, e-commerce, or beyond, our team thrives on tackling complex projects in any domain, leveraging our experience in delivering tailored, impactful solutions for businesses of all shapes and sizes. And today we are talking about AI, right? But as many of you know, the effectiveness of AI initiative heavily relies on the data quality. The chief data officer of Salesforce recently said that AI revolution is actually a data revolution, and the company's AI strategy is only as strong as its data strategy with the trust at its core. That is why I believe it is important to mention that at Binariks, we are not only focusing on doing AI ML, but also on data engineering, software architecture, cloud development, and many other aspects of a successful software project delivery. And today, we are here with insights, strategies, practical approaches to harness the power of Gen AI in document processing. And without further ado, I'll pass the word to my colleague, Bogdan. Bogdan, are you with us? Yeah, let's just give a few seconds for Bogdan.
Yeah, I'm here.
Nice.
Hi,
Yeah.
everyone. So, how do LLMs revolutionize document handling? Let's gonna talk about it. And what I want to do, so let's take a brief journey into the history of document processing and its evolution. A few years ago, I would even say more than a few years ago, we worked on a project that felt like a cutting-edge technology at that time. And we were tasked on converting some scans sent via the emails, and specifically, these were a few types of bills, into a digital format. So basically, the challenge was not about making this document searchable, but we had to extract critical information like numbers, amounts, accounts numbers, and so on, feed them into the database so they can be later automatically linked with the practice management records. Now, back then, when we checked the tools we've used, actually, in the process way, they were a lot of similar to the today's ones, but in the terms of their power, they felt rather rudimentary. So yeah, we relied heavily on the optical character recognition, or OCR, to convert the scanned images into text. And then we used a lot of custom logic involving regular expressions to parse and find the specific pieces of information we needed. It was effective for the specific types of the bills we had. But yeah, fortunately, we had only like 5 or 6 of them. But there were some significant limitations, and the process was often tedious, error-prone, specifically when dealing with bad quality scans, or like when we needed to add support of some other type of bill, even if it looked very similar to the human, it was not a trivial task. So, however, it represented a significant step and honestly laid the groundwork for the future advancements. So now let's have this like fancy motor slide and move to the topic of the new era of document processing. And for sure, we're gonna talk about large language models or LLMs. Nowadays, we have a great buzz over them, and like these are the giants in the AI world, and they're able of processing, generating enormous mountains of text. They generate text that feels like almost it's a human one. For sure, you have heard of them. I'm almost sure that you used or at least tried using some of these applications on your daily basis to automate some of your daily tasks. And maybe some of you tried or were thinking on building some of the software that utilizes them. You may think not only of chatbots, but also some summarizers, as well as like applications that analyze sentiments, help you planning, perform translation, transcription, generate you like or work like a copilot that helps you to write code or text. So, however, they have their own limitations. And when we're talking about limitations, we need to understand that large language models, they're like encyclopedias with a mind of their own. They can generate remarkably accurate information, but they can make mistakes or create information that's not really existing, hallucinate. It's nice to read, but fabricated. Sometimes they may introduce bias, favoring one type of answer over the another because of the data they've been trained on. And mostly when we speak about this kind of biases, we are talking about some smaller language models with less number of parameters. But the tricky part here is that for these models, it's easier to find this hallucination. And when you deal with really large language models, it might be much more harder. So how can we deal with these issues? And the answer is known for a pretty long time now. I believe that a lot of you already have heard about retrieval augmented generation, or simply RAG. Think of this like a tool that helps to keep your LLM grounded in reality, but not any reality you may think about, but yours one. What it means that instead of letting model work with its own vast but maybe sometimes unreliable memory, RAG pulls information from your trusted source, internal documentation, I don't know, rules, handbooks, or your database, pulls not the whole information, but the one that seems to be the most relevant to the question, and provides this to the large language model to generate the not only sound, but precise answer. It's like imagine a lawyer that's working on some very complex case, writing and double checking notes before making critical decision. And this tool can really help in this kind of situations. But even RAG has its limits. It can improve accuracy, but it cannot ensure you that there is gonna be a perfect, absolute precision. Like our lawyer trying to find an exact quote in some like legal document. And like it's not always enough. Because in this case, when you have the generated answer, you cannot always rely on it. So let's go to the real world use case. And yeah, we are talking about project for the first responders. And like, imagine that you're in office where every report needs to be perfect and every detail matters. Just a few hours ago, you worked on the field, saved life, made a real difference. Now you're back at your desk and you're tasked to write each line perfectly. To move all of those actions into some kinds of reports that are backed by laws or some internal documentation or rules that fit into the required formats. So, and you know that it is important, and you know that you need to check everything really with a great precision. So, and this was the place where our tools comes into the play. A simple query typed or spoken instantly provides you with the exact legal reference you need. It's more than just a tool because I would say it's like your lifestyle if you're a first responder, because you use it both in field when you need fast and accurate answers. You use it at work when you don't want to spend all your time to write your reports. It's for the places where precision is a must. Yeah. Second motor slide. Okay. Before digging into solution, small remark. I'll not concentrate on the most of the functionality not related to the so-called AI part, just because it's not the core topic of the today's webinar, but keep it in mind that it was the other important piece, and without it, you cannot have success with the project. So back to the AI part. What was it? To put it very simply, like super simply, client wanted a chatbot that's able to answer questions very precisely, questions of the first responders, backed by laws, rules, or any other kind of specific documentation that's not static. You can imagine that laws may be different across countries, states, and even cities or districts. And initially, client came to us with a working POC that he has already shown to some of the interested parties. Before the initial phase, it was not completely clear how much of the work we need to do, how much we need to change this AI approach. Even we had some insights from this alpha version. So when we first dug into this existing solution, it was clear it's a lot of work to do, because just an overview, the system was using a pretty basic approach of PDF parsing. Thus, like it was not capable of processing complex scans, especially if we're talking about some, I don't know, bad quality, dirty, or whatever. And a pretty simple approach of PDF, I would say, chunking, which you may refer to as dividing the text you have from your PDF parser into smaller pieces, so they could be easily processed and interpreted by machine learning models. For example, LLMs. And yes, it relied heavily on the large language model for generating answers. And it was simple but good track approach that may work in lots of situations. we had a concern on the LLMs for this business case on the question answer generation, but the approach was good. So it was not something we just stated that generating answers may be a bad option. It was actually client's concern that he revealed to us after the alpha user feedback. So of that initial solution. In essence, yes, we faced that LLMs hallucinated, and even when it provided correct answers, it was complex to understand what were these answers backed by, which rules or laws. And as I would say, it may be a very common issue nowadays. As we're talking about building some intelligent AI applications or just using it in your daily life, we tend to get all the information, all the garbage we have, dump into it, and think that it's gonna make us what we want. But it just does not work every time like this. Even after you are working on your prompting, building some chain of thoughts, doing data cleansing, you may find the answers right, but you're searching for the source, and it's not always clear what is the source of this answer. So that's why we decided to work on this chatbot, but convert it more to the chatbot-like application that will not generate the answers, but search for the right answers in that documents we had. So thus we highlighted a few areas of improvement. First one was about document parsing, text chunk generation, and similarity search improvements was the second one. So we're going to talk a little bit more about this later. Why are they so crucial? So let's move on. And here is where our journey really begins. Why is it all about chunking? Let me explain this more in details. So as a human, you're reading the text as a whole. You're interpreting it parts as some kind of symbols you understand, not only like that, okay, here we have lines, here we have sentences. You understand the whole layout. And as a human, you expect your result to be human readable. So actually what we needed to do, what we started doing, is to converting the system into something that could not just parse the text visible on the screen, but to understand its structure, to work like, to act like a specialist, like some kind of librarian that understands where which part lies, and that knows how to parse this document layout, how to understand its connections, and how to provide these answers into the human readable format. We tried multiple formats, multiple approaches, experimented with different layout understanding models. We tried doing some fancy hierarchical stuff when you may think of document being that consists of sections, and sections consist of some paragraphs and lists, and like headers, subheaders, and they consist of sentences. We tried some simpler options when we built some custom logic of the different positions of the text and so on, so on. But the core point here is that we found that getting information on the document structure, making our system work with it, was the very important I would say, the essential part of this. And if we move later, imagine that now you have a system that is able to read the page and say that, okay, here I have some table, here we have a list, and here we have like points of this list, and like, okay, and there we have a title of some new section and few intro paragraphs. So how to make it searchable? And it's all about vector embeddings. And because when we're talking about, we have this OCR layout understanding, but when we're talking in the field of natural language processing, or even any field, machine learning algorithms, they cannot understand text data. They need it to be represented in the numeric format. And vector embeddings, you may think of lists of numbers. These are the representations, and for sure they cannot be random. They need to represent the text itself. They need to represent its characteristics. And as you may already know, or maybe you have an idea, that these vector embeddings are used to compare different text between them. So, and they are like the DNA of our search capability, because they allow to catch the very nuances of the text. So in the typical, for example, retrieval augmented generation approaches, we just use the text chunks we had created on the previous step and generate text embeddings using some neural networks, and that's it. But as you remember, we've created these chunks to be human readable, and what's readable for human is not always readable for the machine, obviously. So that's why we started experimenting with how to enrich this text chunks with some information just for the embedding generation. No, not to show this for the human, but just for the embedding generation. So our model is able to understand what's before, after, maybe what is this section about, or in what subsection are we, and so on, so on. Even some things like which page are we on. This was also a lot of work with a lot of custom logic, a lot of experimentation with some kinds of overlapping, and so on, so on. But now let's think, okay, we have this document understanding, we have this human readable chunks, smart embeddings. So now we could think of the search itself. When we're dealing with this vector embeddings only, our search is like comparison of them one with the other, searching the most similar ones, and providing user with like mapping to the text they represent. But in a lot of cases, this pure semantic search is not enough. So what I'm talking about, it works really well to get the most suitable answers, but sometimes lack inability to place the most relevant ones first. And we really had a great journey of experimentation. We tried to introduce some custom tokenization and lexical ranking. It's like seeking similar based on the exact like word spelling, phrase spelling, comparing the text tokens themselves, not only relying on the semantic search. We tried utilizing some pre-trained re-ranking networks. We also found that there is a very interesting part is about pre-processing, because you need to handle specific jargon and abbreviations that introduce great misconception, especially for this semantic vector embeddings and search based on them. because some abbreviations in the common tongue may have a completely different meaning than this specific first responder jargon. So, and the result was that we have a system that just doesn't just search, but understands the nuances of the documents. So some, I would say, small conclusions that like sometimes you want to build too complicated approaches because they sound nice, but it's not always the case that they work the best. You need to be ready as an engineer, for example, or you need to be ready that your engineers that they may be a little bit frustrated because of this reordering like of your top and answers it's a good thing. If you have a great data set, you must be training your own reordering networks. But if you think that you can rely on some, I don't know, paid API, it works. But for example, in our case, the one popular provided worse results. So it just didn't work there, while there are a lot of cases that it works. So also you need to understand that if you're dealing with documents that are full of tables, you cannot be 100% sure that you have your parsing done right. Especially, I mean, if these tables are not like of one type, very typical, and that's all. If they are different, if maybe sometimes you have some images inside tables, which is very interesting, of course, but it's going to be great pain in where. So, and yeah, that's all takes time. So let's go next. Let's review a scenario, how it may work. But before that, putting it all together, our method was like a master chef, combining all the ingredients we had. Advanced document processing, smart embedding generation. We didn't stop there. So we built a feedback loop. It's very important because we wanted to bring learning later to the system. And this step is very crucial, not only from the implementation, but also from the UX side of view. We set up comprehensive statistics gathering and constantly monitoring not only some performance, but user actions to know your user, to know how to improve your user experience, especially in the chatbot applications that you always want to make like that they're complex underneath, but on the top you want to make them one button. Sorry. So, and as from the architecture point of view, we knew that we were dealing with complex documents, multiple entities that like there may be a lot of problems, and that's the document processing, layout understanding, and all this. It's not a fast process, so we built our architecture in an asynchronous way. You imagine like paying a special attention to this document processing step, so nothing gonna stop it, and it won't affect anything. You can imagine like high-speed multi-lane highway with but for information and with one line for the specific stuff in the system. And with our solution in place, let's review this like not a real world, but use case, so you understand how it works from the whole picture. Yeah, let's move step by step. So imagine a busy first responder department. And where Mr. Johnson, our administrator, he has an essential role. He's not just an administrator, he's like a gatekeeper of our library of critical documents, and every day he adds new documents, removed outdated ones, like modify them. When he uploads them, he adds some fancy name, define categories, so maybe they're easier to be searched. Maybe he even defines some categories, and make sure that everything gonna be structured well. And once Mr. Johnson uploads a document, it goes through the transformative pipeline. Imagine an advanced indexing engine like a librarian with superhuman abilities. This engine breaks the document into manageable pieces, creates a map of every this essential piece lies within the documents. It even knows the exact position of these chunks, physical position on the page. So it can highlight the location in like thousands of documents and 1,000-page document. And this process ensures that when someone searches for information, they can see exactly what they want. And now let's step into the shoes of the first responder, the most user of the system. Time is critical in finding the right answer, maybe the question of life and death. So, and the first responder start by narrowing down the search, or at least he or she can do this. If they know the document category, as I've already mentioned, they can use it, select it, and save a few seconds. But if they are unsure, so they can search across all categories. There may be some drawbacks of this. For example, less precise answer or a little bit longer, but in most cases, they just won't fill that. Next, they ask the question. They can type it or simply speak it. Our system is ready to listen. It's able to convert spoken language into written one. Okay. Now, as the question enters the system, it is transformed like a key fitting to the lock into the format that the system can compare against the massive library of documents. And now the magic happens. The system returns the results. It doesn't just provide an answer, it shows the most relevant documents, highlighting the exact page and line where the answer was hidden. Okay, the first responder clicks on the most promising result, and the document opens directly on the page with the highlighted answer. If the document contains multiple answers, you can think of it, all of them are highlighted, but they simply point on the most likely answer. So, but the journey doesn't stop here. If more questions arise, the first responder can keep the conversation going, asking follow-up questions and getting deeper into the document. And yeah, we have the answer, end of the session. But the chat history is preserved, making it easy to track the investigation, ensuring that nothing gets lost in the shuffle. So, and now let's talk about testing. We've talked about the user flow, and here I'm speaking not about testing in terms of testing of its functional or non-functional requirements, different things, but mostly of the testing of the AI, so the precision of the answers. And it wasn't the final act of our show. Testing was constant companion from the beginning. and it's important. So we started with, I mean, when you want to test your search solution that needs to answer some questions, you're thinking, okay, I'm going to create this question answer set. And we started with a handcrafted, what was thought a solid test set. And spoiler, we were way off the mark. Our initial questions, they were too simplistic, too handbook-like, textbook perfect. Real life turns out to be a lot messier. So then we went with the main try, what we thought will be the best one. We asked the real experts, actual employees of the emergency services, to help filling the test set. And that's when things got really interesting. Their set was really the best, it was great, but as appeared much later, during the first beta, users started using the product. Some of the queries were too complex or too nuanced, but the real tricky thing is here. So in the real world, there may not be just one right answer to some specific questions, and sometimes there are multiple right or almost right answers scattered across like your different documents. And we had to change our approach to testing. It wasn't just about right or wrong. We needed to find all other possible answers, or just sit and analyze the responses, and that's what we did. So moreover, like sometimes you see the result from the right page, but it is some paragraph below or above the really right result. So it's not the right answer, but it's almost right, and you need to count this. And like the conclusion here, it may be not obvious for everyone, that like you have to be ready that when you have more questions and answers in your test set, when you make it larger and larger, and that's what we are always expecting to have, your evaluation results most of all start to get worse and worse. And it's a tough thing for the developers, but you need to understand that if you're working carefully on your test set, you make questions harder, cover different edge cases, add more of them, so the results may get a little bit worse. So, lessons learned. The first one that you need to create a lot of hypotheses, because even when you have some scheme in mind, like dual augmented approach, a lot of stuff is hidden inside your business case, and it's very important. At least currently, nowadays, you just cannot take this one approach and say that it's gonna work out of the box to all the cases you have. Second one, you need to test your theories. You just cannot rely on your idea that, okay, I have this brilliant idea in my mind, it's gonna turn the world around when I finish coding it. So you need to have constant experience. And the second block of lessons, I would say, are about users. You cannot be sure on what the real users are. That's why you want to get as quickly to them as possible, but you still need to remember that you mustn't scare them. So even when you see that your solution is not ready to face some beta users, but you want to start getting some real feedback, that better to find some experts to work with. You need to think about adapting to user feedback from the early beginning. You need to implement it in the way that they're really going to give this feedback. And at first, it's going to work for analyzing some errors, seeing what users are typing, what are the responses. Later, you could use this to make your system learnable. And yeah, you need to balance innovations and fundamentals. And it works both for your approach to some harder stuff, like some algorithms or something like this, as well as something that's considered to be traditional, but still it's very important in the software development overall. So, and like other parts like UX and so on. Values, yeah, we provided scalable MVP for user growth. And it empowered the client to start beta testing with multiple users and attracting new customers. We use the latest and best fitting backend machine learning technologies and make solution able to integrate with other like technologies or integrate some other approaches there in the future. We thought on the user design a lot because, as I mentioned, it is very important in all applications and especially in the applications we want to make simple and minimalistic that are not for the expert users. And yeah, flexible architecture. You need to think of application growth, user base growth, like latency growth, and so on, so on. So that's all. Thanks so much for being with us today. And we'd love to hear your thoughts and answers any questions on this topic. Yeah, thank you, Ross.
Yep. Thank you, everyone, for joining. By the way, you can post your questions in the chat. You can find it down below at the bottom of the Zoom. So yeah, would love to answer those. I have some, yeah. So Bogdan, first question is, does the mobile app always need to stay connected to the server? If so, is it possible to have an offline mode where I can access and query documents?
Yeah, so in particularly our case on the steps that we were yeah, let me answer the question shortly. Yeah, yes, it's possible, but it's a great effort. And it's very possible that you won't have access to all of the documents. It also depends on the amount of documents you're dealing with. We introduced, for example, in this case, not like the full offline mode, but to introduce some caching to gather the most asked questions and to cache them, and some other tricks. But you need to remember that, okay, you may not be able to store the whole vector store on your mobile app. And the second one, that you may not be able to run the effective enough language models on your mobile app. But if you like have time and money, yeah, it may be possible.
Got it. Yeah, we have another question here. How does the AI handle the data recognition and extraction from complex formats like handwritten notes, low resolution scans, multi-column layouts, or heavily formatted documents? What is the accuracy rate, and are there any limitations based on the complexity?
Okay. Let me just read this question because it is a really large one.
Yeah, long one. Yeah.
Okay, how does the AI handle data recognition and extraction from complex formats like handwritten notes, low resolution scans, multi-column layouts, or heavily formatted documents? If we're talking about AI, like some document understanding models, it's all about understanding abstractions, if I would say, because how do you learn that when you hear a word, I don't know, a table, each of one has something in their mind, but the exact table might be very different. I mean, the exact implementation of the table. And that's the way how neural networks are trained. And like most of the machine learning, we teach them to generalize. And if we want to train some custom models to understand some complex formats, first and most important, we check open source. Then we check some paid solutions and see what they have and what they know, what they're able of. If we see that we don't have this, we need to prepare to. We need to be ready to prepare the data sets and of like our own data and train them to have this like some, I would say like handwritten. If you're talking about English, I think that there are applications that deal with this good. Low resolution scans as well, like tables. I've said it's always a problem, and for tables you need to think of some. Like you need to think of some. Maybe there is some structure in it. So the accuracy rate. I'm not sure what's meant here by the accuracy rate, because it depends on what problem you're solving exactly and what model you select.
And how does the system handles the data security?
Yeah, so data security, we had authorization and authentication. We had specific roles to separate the access for the users. And so when we built our solution like in clouds, we made sure that this data storage is limited in access. So even developers did not have like full access to, I mean, all of the production data. We had access to some like test data, but because of the some formal restrictions, level restrictions, even this was taken into account.
Yep. And does the AI system support the multilingual document processing?
Our one was for English only, but it's possible. There are models for like some most used models, most used languages. If you're dealing with some very specific, it might be a problem.
Gotcha.
But most of the well-known languages, you could find models that support that, and not so well as English, but there's what to work with.
And how long did it take for us to deliver that project? Can you remind me that? Because I'm not sure. What was it, 4 to 6 months or something?
Half of a year, I suppose.
Yeah, up to 6 months. Okay. Yeah,
something like this.
Makes sense. 6 months. Yeah, pretty reasonable, like for this kind of product in AI. But do you think this AI solution can be customized for a industry-specific workflows or document types?
It's a separate project.
Yeah.
I mean, like, you have what to start with. You may try to build some POCs, see how it works, but then you discover that there are use cases that cannot be covered with this like very fast and simple solution, and you need to pay attention to your business case and find some specificities of the business. Yeah. So as I mentioned, for example, at the beginning, or not, I don't remember. If you're talking about truck, it's a scheme that has to be extended and customized. And even if you're talking about this basic scheme, there are lots of extensions, like rug fusions and so on. And people are constantly speaking of it. So you take some of this best and and bring custom to it to make it work for your business.
Gotcha. Well, I'm out of questions, me personally. I don't see any more questions in the chat. So yeah, we can probably wrap this up. So thanks everyone for joining. It was good to chat and meet you again. Hope you enjoyed. Any kind of comments, feel free to post on our website, fill out the form, contact us, and let us know if you have any questions further down below.